pre-algebra. We are going to move on with CO47, which is identifying domain and range of a relation. Here are three words that maybe you've heard before, but probably not in the mathematical sense. And so we're going to get some definitions before we kind of start looking at exactly what this is, what we can do with this stuff. Okay. So a relation is essentially a collection of ordered pairs, and it can be represented a number of different ways, but we're going to look at it in the context of a table or a graph. A collection of ordered pairs, and we're going to look at it as a table or a graph. So you can see the three relations I've got below here. I've got one table and two that are graphs. They're similar, but a little bit different. We'll talk about that shortly, but those are all just relations. Collection of ordered pairs. The domain of a relation, the x values of a relation. All the x values that are included in the relation are what we call the domain. Can you guess what the range is? The y values of a relation. Now, I'm making an assumption here that you have done corner plane and graphing before.
Oh, yeah.
Okay. Jeffrey, turn around, please. So you are familiar with the x and the y axis? Which one's x and which one's y? Abby?
X is across and Y is up and
X is the horizontal and y is the vertical. So if you don't know that, maybe just jot it down. It is labeled here, I believe, on these two. There's your x, there's your y. This one's labeled x, y there too. So it is labeled, but won't always be. Especially when you write your own or when you draw your own corner plane. So if you don't know that, maybe just take a minute to jot it down. But domain and range. Questions so far? Got the definitions?
Yes.
Okay, so looking at these types of relations here, how to find the domain and range of a table. What are the x values in this table? Tony?
Negative 10, negative 5, 2, 4, 0.
Yes. Negative 10, negative 5, 2, 4, 0. When you're given a table, the domain is just listed there for you. So you essentially just need to rewrite it and say, what's the domain? The domain is negative 10, negative 5, 2, 4, 0, right? All these x values. Same thing for the range. The range is going to be the y values. Negative 3, 0, 8, 2, negative 1. Just list it out.
Was it be in order?
Sorry?
Should it be in order?
They should be in order. Yep. So that you can kind of match up with the ordered pairs, like negative 10, negative 3 is an ordered pair in this relation, so you kind of want them, matched up there. So for a table, just list them. They're listed there for you. Okay. When you're given a graph, though, things are a little bit different. Because in a line, for example, what do we know about a line?
Straight.
It's straight. What else? Doesn't end. Goes on forever, right? What about this figure tells you that it's a line and then it goes on forever? The arrows. Okay. So if I asked you for the domain of a line, well, you're never going to run out of things to say, right? You're never going to run out of x values that are included because it extends beyond just what's written here. The x values of this line seem to be, well, it goes from about negative 6, and then it goes to about 3 here on the x-axis. Well, no, it continues on, okay, forever. And so all real numbers make up the domain, and there's a little symbol for that. It's a double-stemmed R. Maybe you've seen it before. It looks like this. Kind of make it 11, and then start at the first vertical line and make an R like that. That's the mathematical symbol that essentially means everything. Okay? Only. only you can have that. Right?
She's
So if the domain of a line, because it extends on forever, all real numbers, or you can just write this double stemmed R, and that's the symbol. Okay,
What would be considered a not real number?
not real number would be like the square root of -9. Because you can't take the square root of a negative number. That's where we get to like imaginary numbers. You'll cover imaginary numbers in Algebra 2, you know? Because eventually, math teachers, we just run out of things to teach, so we kind of just make stuff up. Hey, let's just teach about imaginary numbers, because that'll confuse them. Jeffrey!
Okay, so I have a question about something. So, since we're in pre-algebra right now, and then 8th grade will be algebra,
Yes.
and then in high school, are they gonna have like algebra 1 and 2?
So it depends on where you go, kind of because you all kind of spread out different. But typically, after algebra, you would either take geometry or algebra 2. Those are kind of interchangeable courses. Geometry usually comes first, but doesn't have to.
So what about, like in freshman year then, since, like let's say, this is probably not true, but let's say all of 7th grade goes to TG, and like were all the kids that were in algebra 1 in 8th grade, or not algebra 1, algebra 2 or geometry or whatever you
Geometry.
said? Yeah. Will some of us go to like that, like?
So if you take algebra your 8th grade year, you would most likely move into geometry. If you take geometry your 8th grade year, then you'll most likely move into algebra 2.
Okay. How did they?
Good?
Yeah.
All right. John,
But what if you're in algebra too?
your 8th grade year?
Yeah.
Then probably a pre-calc class. If you're in pre-calc your 8th grade year, which Mr. 291 was here, then you take calculus your freshman year.
What if you're in calculus?
And Calc 2.
What if you're in that?
Guess what comes next?
Calc
Calc 3. And then Calc 4, then Calc 5.
Wait, what comes next? Where does it end?
Calc 5.
It really doesn't end. I mean, you're kind of teetering on the philosophical question. What do humans invent math, or is math always there and we just discover it? It's the latter. The mathematical relationships, humans didn't invent. We might have invented how to represent it, but 2 and 2 is always made 4. We just didn't say it does. That quantity and that quantity always makes that quantity. So, sorry, to answer your question, where does it end? We don't know where it ends. And that's why we need, some people to care about what's going on here so that you can learn enough to be able to figure out what comes next. The things that you hold valuable, your technology, your TikToks, your smartphones, they are mathematically based. If there weren't people that discovered the application of the math, we wouldn't have them. So, Lexi.
Does this school teach whatever that guy was in?
He was an independent, so I had him in my 8th grade geometry class, and he was just beyond that. So he kind of did his own thing. He taught himself pre-calc, basically, with a little help from me here and there. But anyway, so during the lessons, he would just be buried in the book. He would take the test, ace them, and then just kind of. So no, it'd be an independent study type of thing. Jeffrey.
Okay, so my
So
last
many
question kind of got sidetracked.
Yeah,
What I was
it did.
basically trying to say is, whatever like math class you are here in 8th grade, does the high school know? And then do you pick it, or do they just put you in the next?
Again, depends on where you go. Some high schools have placement tests. Some high schools just let you sign up for wherever you want to. Your grade that if you take next year for high school credit, which you are able to, that grade will transfer. It will follow you to whatever high school that you head to. But there are certain requirements that you have to meet. If you don't pass all of your POs, if you get a D in the course, then you'll retake that in high school because they won't accept that.
Okay.
That answer your question?
Mm-hmm.
Oh, good. Phew, Kylie.
What happens if you take the class and you're getting all A's and it's too easy for you? Do they make you move up to the next class, or do you pay for yourself? If it's too easy for
If you absolutely rock algebra next year, could you take algebra again in high school? Is that your answer?
Yeah.
Yes, you could. Yeah, if you don't want the grade to transfer over, then it wouldn't have to. In high school, if you took algebra your freshman year, you rocked it, you're like, I want to do algebra again in 10th grade year, then you wouldn't be able to do it. So from 8th grade to 9th grade, you have the option of the grade to transfer. Once you're in it, then you have to progress. Tony!
So basically that 291 guy was a genius.
Quite bright.
He grew up to be Albert Einstein.
He's only like a freshman in college, so he's still growing. Anyway, how do we get from here? Thanks, Jeffrey. That was a fun little trip. So the domain of a relation, all real numbers, or that double stemmed R because it goes on forever. The range is going to be similar, right? If a line continues forever horizontally along the x-axis, it's also going to continue forever along the vertical axis. And so the answer is the same. All real. Well, that's how we got to it. We asked about what's a non-real number. That's how we got there. Now I remember it.
So it's not my fault.
So for any line, anytime you see a graph with arrows, you know you're dealing with a line. Your domain and range will always be all real numbers because that line goes on forever. Okay?
What are those?
The other type of graph that we're going to talk about is a segment. And what is the difference between a line and a segment? You can see there's a little bit different in how it's presented here, other than one's going up from left to right, the other one's going down from left to right, and they also mean different things. Jack?
Well, the segment, instead of having arrows, it has clear spots where it ends.
Right, a segment has a beginning and an end. Back when I was in school, I irritated all my teachers when they'd say, like, line up for lunch. I'd say, well, actually, it's a segment because it has a beginning and an end. They didn't find it funny, right? But you can do that to your teachers now, right? But so a segment has a beginning and it has an end. And you know that because rather than arrows, it's got the dots there, right? So when we talk about the domain of a segment, all of those x values that are part of a segment, we look at where on the x-axis this segment travels, right? The point on the left is at -1 on the x-axis. The point on the right,
Speechless.
something to share?
No.
Then stop talking and sit flat, please. Thank you. The point on the right is at +5 on the x-axis. So the domain of this segment seems to travel from -1 all the way to 5. But unlike a table, we can't just write, -1, 0, 1, 2, 3, 4, 5. Why not? Why can't we just include those integers here if I'm asking for all the x values that this segment covers? Wyatt, what do you think?
And you have to go up and down with the y.
Well, let's stick with the domain first. What I'm saying is here, we can see that on the x-axis, if you look at the point on the far left, the x-axis, that point is at -1. The point on the right on the x-axis is at +5. And we can't just write -1, 0, 1, 2, 3, 4, 5 like we were able to with the table. Why can't we do that? John?
Actually, I have a question.
Let's save it for now. Let's not get too far off here.
Just a really simple one.
Just save it, please. Anyone?
Wait, what?
Why can't we just write, if we see that this segment on the x-axis includes values from -1 to +5, why can't we just list the numbers from -1 to 5 like we did with the table over here? John?
Is this not how it works?
True. And why is that? What are we missing here? If I just write these integer values, what am I missing? What am I leaving out?
Don't you have to say which point the dot is on the outside?
Well, we're looking for the beginning and the end of the segment. It begins at -1, it ends at +5. But if I just write those numbers, what am I missing? Shay, you're kind of no. What about fractions and decimals, right? Isn't like 2.5, part of that space from -1 to 5? Does this segment not cross x or not have an x value at 2.5 or 1.8 or 5/4, right? everything in between -1 and 5 is included because it's a segment. It's not a table where it's just listed out. So to write the domain of a segment, you put that beginning number, -1, and then you show everything else in between there by using an arrow. -1 to +5. Everything in between. All the fractions, all the decimals, everything. Okay? So then for the range, I'll do that one in blue. We're looking at all the y values of this segment. What's the lowest y value that this segment has? Look at that y-axis. What's the lowest y value this segment has? Emil? 1, right? The bottom point there we can see is that 1 on the y-axis. What's the highest y value this segment has? Y? 7. It goes all the way up here to 7. So everything between 1 and 7 is going to be a part of the range. So similar to the domain, we're going to put 1, arrow, 7. Everything from 1 to 7 is included. Tony?
It goes to 8.
Sorry?
It goes to 8.
The coordinate plane goes to 8, but look where our segment stops. Our segment does not go all the way up to 8, right? Our segment stops at 7. Yeah?
There are more fractions or decimals.
Are there more fractions or decimals? There's an infinite number of each. Yeah, there's an infinite number of each. Like if I started with the decimal 0.1 and the fraction, let's say 1/2, I could just, here's 0.11. Well, here's 1/22. Here's 0.111. Here's 1/222. Here's 0.1111. Here's 1/2222. Right? I just keep adding digits to it forever. And so, yeah, it is crazy. In fact, there's an infinite number of values even between 0 and 1. If you were to start writing all the numbers, all the decimals from 0 to 1, you'd never finish. There's an infinite number of them. Number system's crazy. We're talking about some heavy things. Yesterday, my word counting down thing, and now this.
The
Like, this
conspiracy
is
theory.
some heavy stuff. John!
This is like a question, but for like, say, if I want to be a computer programmer,
Yeah.
would there be like math?
Yes.
There's math and everything.
Yes, there is math and computer programming.
Is there math?
If it's not calculation, it's the logic piece of it, right? How does this affect this? Which is, geometry is like the study of logic. And you have logic in your math packets too. It's that kind of stuff, maybe more than calculation, depending on what you're programming. Okay.
Who figured all this out?
Who?
Yeah.
I do not know the name of the guy or gal that kind of put this together, but if you come up with something super famous like Pythagorean Theorem, you've probably heard of that before.
Who did it?
Pythagoras.
What is the theorem?
I've heard of
It has to do
pi.
with like right triangles.
Are we
geometry
doing this?
I think we cover it at the end of the year. I think.
Let me see.
Liam.
Do you think there's more doors or wheels in the world?
Now there's a question: doors or wheels?
Wheels.
I would say
Wheels.
Doors.
Because there's four wheels on a car.
There's 4 doors.
Well, are we talking about like, yeah,
Five, technically.
Liam, are we talking about like all types of wheels?
Yes.
Like
Yeah.
Matchbox car wheels then, I would say.
I'd say
Except like on cars, there's still doors on cars.
There are, but then you have
And
the
on
big
your
semi
Matchbox
trucks.
cars.
There's more wheels than doors on semi trucks.
But there's also doors on the
Then there's
back.
bicycles
Liam, are you for doors?
that doesn't have.
Good.
They don't have any doors.
Well, I'm just explaining.
It doesn't say anything about.
That
3, 2, 1. You are quiet. Lexi, are you going to bring us back to math, or are we going to continue this?
The conversation.
Yes. Oh, there's wheels on trains. Oh, trains have doors. Go ahead. Sorry.
Do you think there's more hair or grass?
It's grass.
Hair or grass?
Blades of
Grass.
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 Gosh,
Old
with the
people.
way that our landscapes are being
They're
snapped
digging
up
up
for
grass.
Cancer.
duplexes and mega malls.
I said it.
I'll probably still go with grass.
Yes.
Final answer. Tony.
says nothing about the I can do stuff on the Jaeger and
Nothing? Well, then we'll add it in there later. Okay. Questions on this? All right. Let's get the more complicated of the two are definitely the graphs. So we'll kind of talk about them again here. What type of graph am I dealing with in this first example? Jeffrey, turn around, please. Is this a line or a segment, John?
segments.
Segment. And you know that because how?
Segments in it, and it's also
Okay, so I'm going to plane, but how do you know it's a segment versus a line?
because there's segments.
What do you mean by that?
Words.
And it doesn't have arrows.
Doesn't have arrows, right? You know it's a segment because of the lack of arrows, which means that this is where the segment begins. This is where the segment ends. Okay? So when we're looking for the domain, we're looking for that beginning and ending point on the x-axis. What's the lowest point or the lowest x value, the first x value of this segment? Haley? I think it's actually -4. This is kind of numbered weirdly, but -4. Okay? And what is the highest x value or the rightmost x value? Abby?
5.
+5. So on the x-axis, this segment begins at -4, and it goes all the way across over to +5. So to show that, we start with -4, we put our arrow here, and then it ends at 5. That ensures that all the fractions, all the decimals, all that stuff is included. Okay? Now for the range, what's the lowest y value that this segment has? Look at how it travels along the y-axis. What's the lowest y value? Dave? +1, right? Our bottom point here is at 1 on the y-axis. So that's going to be our first number there. And what's the highest y value that this has? Our top point right here. What does that kind of correspond to? Sophie? 3. So the range of this segment would be 1 to 3. Jack?
Wouldn't the arrow technically be wrong because the line doesn't exactly meet up at every junction?
What do you mean?
So the arrow says it needs. Oh wait, never mind. Because that includes.
Yeah, what the arrow basically tells us is that every fraction, every decimal in between 1 and 3 is a part of it. It's not like a table where they're individual numbers listed out. Okay, if we can't possibly write all the decimals and all the fractions on the paper, we use the arrow to kind of show beginning and end. Right? Second one, what do we got? It's a graph, but what type? Griffin?
It's a line.
It is a line. And how do you know?
Because it goes on forever.
And what tells you that?
The arrows.
The arrows, right? So because it's a line, what's our domain and our range? Look back at your notes from a section above. Because it's a line, what's our domain and our range? Jack?
Fancy R.
The fancy R, yeah. That double-stemmed R, okay? Or if you want to write all real numbers, that works, okay? Or that double-stemmed R, either one's fine. But everything is included, okay? Everything is included because it goes on forever. There is no beginning, there is no end. Third one, what do we got? Blake. It's a segment, okay? So we look at, for the domain here, where on the x-axis does this segment travel? What's our lowest x value? What's our highest x? So on the x-axis, that point seems to be -4. Okay, again, it's kind of numbered strangely. Is it -4, -5? How you can tell is you can just count over -1, -2, -3, -4. So -4 is the beginning point, and you said 5 is the ending point. We're looking at the x-axis here. I think you're kind of jumping to the range, the y-axis. Our ending point on the x-axis is where? Camille? -1. Right? So the domain of this goes from -4 to -1. Because where this first point is, make a tick mark on the x-axis. Where our second point is, go down to the x-axis,
Oh.
right? That's where the segment travels on the x-axis.
At the
I should say on the x-axis, but within the x-axis. Then for the range, we'll do that with the y. We'll do that in red. Okay. What's the lowest y value of this segment? Where on the y-axis does it begin? Kylie?
I think it's 0.
It is, right? Look at our bottom point. Where on the y-axis is it?
0.
0. Then go up to the top point. Where on the y-axis is it? Jack? 5. Right? Here's our top point. Y-axis, 5. So the range, 0, arrow, 5. Okay? Questions on that? Segment's definitely the hardest one. Right? The table, you just list it. A line is always the same thing. That segment, you really got to look at it and look for that domain and the range. So, Quinn,
I don't understand the whole thing.
when you say the whole thing, you mean like from the very start of the lesson until right now? Okay, we should talk later then. I can re-teach everything. All right. So let's go to the backside. Okay. It says make an XY table or a graph with the given domain and range. So you can't always use a table, right? Because a table would be easier, but if you're dealing with the graph, then you can't use a table because you have to include all those decimals and all those fractions. So you gotta look at the information given and decide, what is this saying? Let's look at the first one here. It says that domain is specifically -4, -1, 6, 0, and 2. When you've got values specifically listed out like that, what are we talking about? Is that a table or is that a graph? Table, right? Okay? So we're going to make our XY table here. And which values do the domain represent? The X ones. So in our X column, -4, -1, 6, 0, 2. Okay? So Quentin, if the domain refers to the X values, what numbers are we going to put in the Y column here? Yeah, the range, right? 3, -4, 6, 10, -1. Since you look at this page here and you're deciding, is it a table or is it a graph? Anything that's listed out with that using commas, you're going to be dealing with a table, right? The next one straight across from that, this is in a little bit different notation than we did on the front side. I reordered things and forgot to change how it's presented. So this, what we have here, is the same thing as what we wrote on the front side, -3, arrow 5. This right here would be the same thing that we wrote on the front side, 2, arrow 4. Okay. So what is this going to look like? Is this a table or a graph? Graph. What type of graph? Segment, because it has a beginning, it has an end. So now the question becomes, how do we put this as a segment on the coordinate plane? Thankfully, there's a nice, easy trick to do it. Okay? Your first X value, that -3, and your first Y value, that 2, put those together to make an ordered pair. -3, 2. And that ordered pair gets plotted on the coordinate plane about right there. Wouldn't you say? That's about -3 and about +2. -3 on X, 2 on Y, give or take. What do you think our next ordered pair is? Camille? 5, 4, right? The high X value and the high Y value put those together to make an ordered pair. 5, 4, which also gets plotted on the same corner plane. And so 5 is going to be right about there, 4 maybe right about there, right? 5 on X, 4 on Y. And what we have here now is a segment that on the X-axis goes from -3 to +5. Exactly what that says there. On the Y-axis goes from 2 up to 4. Exactly what that says there. Okay? The segments are the trickiest of the three, but if you get that setup down, take the low and the low, the high and the high, plot those ordered pairs, connect the dots, you've got your segment. Okay? So the one right below it, domain. 1, and again, this is the same notation as saying 1, arrow 4, and 2, arrow 5. What ordered pair are we going to be plotting? What ordered pairs are we going to be plotting? Tony?
1 and 2 and 4 and 5.
1, 2, right? Take the low and the low and the low. 1, 2. Then take the high and the high. 4, 5. Those are going to be the two end points to your segment. Okay. Questions? All right. Homework for tomorrow. There's no con tonight. So what time you would be spending doing con, you could do this instead. Tony? Yeah, that was not finished yet. Your answer needs to be this graph there. All right? We'll talk about it tomorrow. Sophie?
So is this like an assignment or is it optional?
It is not optional. It is an assignment that is due tomorrow.
Just the
Like
graph?
The rest of the page. Yes, all 6 remaining questions. 5.5 remaining questions. All right. That's our math, folks.
Don't forget to like and subscribe.